All right, so in this video, we're going to be talking about even and odd trigonometric functions. I'm just going to read this insert, this introduction from the book. It says, to be able to use our 6 trigonometric functions freely with both positive and negative angle inputs, we should examine how each function treats a negative input. As it turns out, there is an important difference among the functions in this regard. And deep, so as a reminder, the odd functions, for the odd functions, if your input is negative x, the output is the opposite of what it would be with a positive x. For the even functions, if your input a negative x, the output is the same as if you would have put in the positive x. And of course, there are functions that are neither odd nor even, that don't follow either one of those patterns. With that in mind, let me remind you of some even functions that you know and give you some examples of even and odd functions. So one of the even functions that you know is quadratic function. So quadratic function takes an input and it squares it. So if you had a positive input, let's say positive 2, what it does, it squares it and you get a positive 4 as the output. What happens if you input a negative 2? If you input a negative 2, again, it squares it and you still get a positive 4. So if you put in the positive input or negative input of the same absolute value, the output will be the same. Okay, so your f of negative x is the same as f of x. No difference. And because of this property, these functions are symmetric on both sides of the y-axis, because your positive 2 gives you the output of 4 and your negative 2 gives you the output of 4. Your positive 3 gives you the output of 9 and the negative. So these points are mirror images of each other, right? Across the y-axis. So your even functions are symmetric about the y-axis. That's how you can recognize them from the graphs. Now, what about odd functions? Well, again, one of the famous odd functions that you know is x cubed, is a cubic function. So, for example, if you put in positive 1, this function cubes it and you get a positive 1 as an output. If you input a negative 1, then the function cubes it and you get a negative 1. So the inputs are opposites of each other, right? When positive and negative, the outputs are also opposites of each other. They're not the same. Like in case of the even functions, they would be the same. In case of the odd functions, they're going to be opposite of each other, meaning one positive, one negative. Okay, so let's try it again. Let's say f of 3. Um, it's 3 cubed, which is positive 27. F of negative 3 will be negative 3 cubed, which is a negative 27. Again, the opposite inputs, the opposite outputs. That's an odd function. That's a definition of an odd function. So formally, it's written like this. F of negative x is the opposite of f of x. So the output of negative x is the opposite of the output of positive x. Okay, now from the graph, you can recognize such function because it is symmetric, but in a different way. It's symmetric about the uh, origin. And what that means is that you can, if you take this branch of the function and rotate it 180 degrees, then you're gonna get the second branch. So it's basically rotation, like it's symmetric about the origin, so it's rotated 180 degrees about the origin. Okay, so what kind of symmetricity can we see with trigonometric functions? Well, let's explore it a little bit. So here we have our unit circle, and we have a positive t angle and a negative t angle. And let's compare the inputs. So the inputs and the outputs. So here we know um, this coordinate, the coordinates of this point are x and y, and this is x and negative y, right? So sine of angle t is going to be the y, and sine of negative t is negative y. So what kind of symmetricity do we have here? Is it odd or even function? So opposite inputs, opposite outputs. So that's a property of an odd function, right? So sine is odd. What about the cosine? Cosine t is your x value, and cosine of a negative t is also going to be the positive x value, right? So opposite inputs, same output. So that's a property of an even function. All right, let's continue. Tangent t. Tangent t is y divided by x, and for t, both are positive. Now for a negative t, um, the x is positive, but the y is negative. So we have negative y over x. So it's negative, the opposite of y over x that we see in tangent for a positive angle t. So again, the opposite inputs give you the opposite outputs. So this again is a property of an odd function. So cotangent will follow the same pattern. It's the positive x over negative y, which gives you negative x over y, which is the opposite of when we have a positive input. So again, cotangent is an odd function. Well, let's examine secant and cosecant. So secant function is 1 over cosine, right? So it's 1 over x. Okay, and for the negative t, the x value is the same. It's positive, so it's 1 over x. So opposite inputs, the same output. That's an even function. So even function. And for the cosecant, we have a 1 divided by y, and for the negative t, y is negative. So it's the output for the opposite inputs, the outputs are also opposite. So that makes this function an odd function. So out of all 6 trigonometric functions, we have only 2 even functions. That's cosine and secant. And it makes sense because secant is the inverse of cosine, so functions, so they are connected to each other. So secant is just 1 divided by cosine. So if cosine is even, then the secant is even as well. The rest of the functions are odd, which means that for the negative input, they're going to have a negative output. And in case of cosine and secant, for the negative input, they have a positive output. So in the next slide, we have a summary of what we just were talking about. So in general, for the even function, negative input results in the same output as if the x was positive. And in the case of odd function, if your input is negative, the output is opposite of what it would be if your x was positive. And cosine and secant are both even functions, and the rest are odd functions. And let's see how this knowledge would help us here. In this example, we know that the secant of t equals 2, and they want us to find the secant of negative t. And we know that the secant is an even function, and that means that the output would be the same as if the t was positive, so it's also going to be equal to. All right. I want you to try this one. If the cotangent of t is square root of 3, what is the cotangent of negative t? And we're moving forward. Actually, I would like to stop this video here, and I'm going to see you in the next one.